In this video, we're going to talk about function pointers. So we've seen pointers in some of the previous videos, and we've also talked about functions. C lets us create pointers to functions as well. So I've created two simple functions that should be relatively easy to understand. One's a power function that has a for loop that raises x to the nth power by multiplying x times itself a multiple number of times. Then here's a max function that returns the greater of a or b. And then in my main method, I create two numbers that are integers, and I call power and max on both of those. So let's just double check that our program works. Okay, and so it does. It gets the results that we would expect. Now I can declare a function pointer. And let me just go ahead and put a note here that these are calling the functions directly. And I think I'm also missing a return. So I'll add that. So now I'm going to define a function pointer. And it's going to be a pointer that returns in a function pointer to a function that returns an int and takes two int parameters. And then here, I'll say function pointer is equal to the address of power. Actually, I think I can just do power there. And then to call that, I'll say function pointer, and we'll do num1, num2. And let's go ahead and do that inside a print statement. So I think that's the same one we had before. So that should work. Let's just double check that our syntax is correct. Let's build this. Yeah, and you see that it calls power just as it did above. So now let's set that equal to max. And let's print that we'll say that we're doing it with a function pointer here. And again, notice we're calling power, but we're calling it using the function pointer. And one thing to notice is I'm putting in parentheses when I dereference that function. That's to make sure that it gets dereferenced before it tries to do something with it. So now once it dereferences this, it's a function and it'll apply it to this parameter list, and the same thing below. So let's compile and run. Okay, so that looks good. And let's do one other thing. Let's create a function. First off, let me make a note that this is a function pointer. So I'm going to write a function called do something. And it's going to take a function that takes two integers, returns an integer. And then it's also going to take two integers as parameters. And it's going to evaluate the function pointed to by f pointer with x and y as parameters. So it'll return f pointer function applied with parameters x and y. So the first parameter here, which is int f pointer int, is a function pointer to a function that takes two int parameters and returns an int. And the second parameters are the two integers. So now we're going to do all of this over again. So here we're going to call the functions using a function. So I'm going to call do something power num1 num2, and I'll do the same thing here, except I'll call max. So notice the function is a parameter to this other function. And notice all three times we get the same result, which is what we would expect, but we're calling the function three different ways. So in this first example, we're calling them directly. In this example, I'm using a function pointer to call the function. And here I'm passing the function to a function that'll call and evaluate the function. So there's a lot that you can do here. And this really gives C a lot of power. And in fact, you can even use the idea of a function pointer to do something like polymorphism. For example, the way you can do it in C++, you can also do it in C using function pointers. And there will be an example of that